Now we go into the mass of the atmosphere. What does it consist of? Is it even made of mass? Yes, it is made of mass because of the air molecules or the gases that exist in the atmosphere. And the atmosphere exerts a downward force on the Earth because of gravity. So gravity affects, has an influence on the mass in the atmosphere. It pulls on the mass of the molecules in the atmosphere towards the center of the Earth. And when there is more mass on top, then there is more force being felt by an object at the bottom of that mass. So we can write that in an equation where it says, which can be written as F is equal to rho g, where F is the force exerted on a surface, is equals to the density of the material or the mass on top of that surface multiplied by the gravitational constant, or g. So from here we see that if the density is large, then the force will be large, and if the gravity is large, then the force will also be large. But on Earth, the gravity is more or less a constant at 9.80 meter per that's the gravitational acceleration constant at 9.80 meter per second square, but the density of air is also can be considered constant at the bottom of the atmosphere. So when you multiply the two numbers, and you get a persistent force being exerted upon that surface on a location on the Earth. Now this force is related to pressure, because pressure is equals to force over an area. So we can calculate the pressure by adding up all of the forces that exist, that exerts on the surface to the top. So P is equals to the addition of all the density multiplied by the gravity from the bottom 0 until infinity, or until the top of the atmosphere, multiplied with the distance. And there I write the gravitational constant, gravitational acceleration constant, 9.807 meter per second. There's a typo there; it should be meter per second square instead of meter per second. Then we can substitute the rho g. We can bring the g out of that equation, because the constant doesn't change with height, to just say that P is equals to the summation of the density from 0 until infinity, or to the top of the atmosphere, multiplied by the distance in the difference in height, multiplied by the gravity. So in other words, simply, because most of it, like say, not most of it, but then if you're interested at the surface of the Earth, which we are living most of the time, so the amount of the density would be more or less constant, and the gravity is also constant, and so the summation of 0 to infinity of rho times dz is equals to the mass, or m, and then g is also constant. So in the end, the pressure at the surface of the Earth is just the mass multiplied by the gravity. Now, just for your information, the unit of mass there is, it's not mass means kilogram. It's actually kilogram per meter square for a certain area, multiplied by the unit of the gravitational acceleration constant, or the meter per second square. And I did write a note there where m is the mass per unit area. So let us try to use the equation to calculate the amount of mass there is in the atmosphere. So the question is, if the globally average surface pressure is 1010 hectopascal, hectopascal is a common, HPA, hectopascal is a common pressure unit used for the atmosphere, then what is the mass of the atmosphere? Of course, if the amount of pressure in the atmosphere is high, then the amount of mass is also will be high. We start off by writing the equation, which is, as you recall, pressure is equals to mass times gravity. And we need to calculate mass. We know what gravity is. We know what pressure is. So we rearrange this equation to become m equals to P over G, where G is 9.807 meter per second square, and pressure is 1010 hectopascal, or in Pascal is 1010 times 10 to the power of 2 Pascal, or 101000 Pascal. That means 101,000 Pascal. We substitute this into the equation and we will get 9.807 10299. The unit is kilogram per meter square. That means the amount of mass per a unit area, a unit meter square area. Now we want to calculate the mass for the entire globe or for the entire Earth. So we need to know the amount of surface area of the Earth. Now we can do that by using an equation to calculate the surface area of a sphere, which is A equals to 4 pi RE square. Now RE is the radius of the Earth, which is a constant. We can assume it to be a constant, where RE is equals to 6,370 kilometers, which is also equivalent to 637,000 meters. Substitute this into this, then we will get a surface area of 4 times pi times 637,000 square, and this would give us 5.10 times 10 to the power of 14 meters square. Now we have the surface area of the Earth. We can use this to multiply with this value here to calculate the amount of mass there is in the atmosphere. So mass total is 10,299 kilogram per meter square, multiply with 5.10 times 10 to the power of 14 meters square would give us, write it somewhere at the bottom, I hope you can see it, it's 5.25 times 10 to the power of 18 kilograms. So that is the total mass of air there is in the atmosphere for the entire globe, or approximate mass of air there is in the entire globe. Of course, this is dependent on the average pressure of the atmosphere at the surface.